What if I told you Earth is playing a high-stakes game of cosmic billiards? A game where one stray shot, one invisible nudge in the void could change everything. We're not talking about asteroids, not comets, but something far larger. A system-wide dance of gravity, motion, and chaos where the tiniest misstep could rewrite the fate of worlds. Welcome to the invisible arena where planets, stars, and satellites move in a perfect rhythm. Until they don't, this is orbital billiards, and the next collision may already be in motion. Before we dive deeper into this cosmic game, hit subscribe and join the mission. Because what you're about to see is not science fiction, it's happening right now, above your head. From space, Earth looks serene. A marble of blue and white, gliding through the dark, orbiting safely in the narrow zone where life can thrive, but that calm is an illusion. Our planet's path is a thread through a web of forces, gravitational pulls, orbital resonances, and invisible debris fields, all shifting, all competing, all precariously balanced. Astronomers call it the dynamic solar system. We might call it a cosmic dance floor. Each planet, moon, and asteroid follows the choreography dictated by gravity. But here's the thing, the dance never ends and the steps never repeat. Every orbit, every spin, every alignment changes the game ever so slightly. Picture the solar system as a gigantic billiard table. The sun is the cue ball, massive, controlling, commanding. The planets are the billiard balls, moving in circles, colliding gravitationally, sometimes even knocking others out of their paths. And every so often, a new ball rolls in from the darkness, an interstellar visitor, a rogue comet, a fragment of something ancient. That's when the game gets dangerous. Because on this table, there are no rails, no boundaries. Just infinite space and the unpredictable consequences of motion. They come quietly, the wanderers, fragments of ice and rock, traveling for millions of years before crossing our path. Some are familiar, like Halley's Comet or Apophis. Others are strangers, from systems we'll never know. Right now, NASA's Planetary Defense Coordination Office tracks thousands of these objects, each one mapped, measured, and projected decades into the future, but even the best systems have limits. For every asteroid we've found, there are many we haven't, small, fast, dark objects that reflect almost no light. Objects like the one that exploded over Chelyabinsk in 2013 with a force of 500 kilotons of TNT, and no one saw it coming. Now, imagine something 10 times that size. Or a comet not bound to our sun streaking in from interstellar space. Astronomers estimate at least a few such visitors cross our solar system each year. Most pass harmlessly, but not all. Apophis, the infamous god of chaos, will pass closer to Earth in 2029 than our communication satellites. It will be visible to the naked eye, and though calculations show no impact, even scientists admit gravitational uncertainties exist. What if Jupiter's tug or Earth's own motion shifts its course just slightly? A few thousand kilometers today could mean collision decades later. This isn't speculation, it's celestial mechanics and chaos theory. Every object in space interacts with every other. One small nudge can start a chain reaction across the entire solar system. In space, there are no engines large enough to hurl a comet across billions of kilometers. Instead, gravity does the work. Scientists call it a gravitational slingshot, a trick shot of the cosmos where a smaller object steals momentum from a giant. When a spacecraft passes near Jupiter or Saturn, it uses that planet's motion to accelerate, a technique NASA has perfected, but the same laws apply to comets and asteroids. If a comet passes just behind Jupiter, it can be flung outward at tremendous speed, ejected from the solar system entirely. If it passes in front, it slows, sometimes captured, sometimes redirected toward the inner planets. Now imagine this: a rogue comet from deep space enters the solar system at an odd angle. It brushes past Jupiter. The gas giant's immense gravity slings it into a new orbit, one that intersects Earth's path in 50 years. All because of a single close approach, a tiny deflection, and a chain reaction of motion. Think of it like a cosmic game of pool: Jupiter the cue ball, the comet the target, and Earth the pocket. You don't have to hit directly to score a strike. Simulations show that even millimeter-level deviations, compounded over decades, can shift an object's position by thousands of kilometers. That's why orbital prediction gets fuzzy beyond a few centuries. The solar system isn't clockwork, it's chaos wrapped in gravity. Let's imagine the unthinkable: a collision. Not a doomsday asteroid, but a 10-kilometer fragment of rock, accelerated for millions of years by gravity. At impact, it hits Earth at 20 kilometers per second. That's 44,000 miles per hour, the kinetic energy released. Roughly 100 million megatons of TNT, enough to vaporize everything for hundreds of miles, to darken the sky for years. To trigger an extinction, it's happened before. 66 million years ago, a rock smaller than this wiped out the dinosaurs. What saved us, every day since, is probability, not permanence. Most debris burns up harmlessly in our atmosphere. Some become beautiful meteors, streaking across the night sky. But a few, the big ones, wait in the dark, biding time. Scientists simulate impact scenarios constantly: angle of entry, atmospheric resistance, geological effects. Even a shallow-angle strike in an ocean could cause a mega tsunami reaching continents within hours. Every night we look up at the stars, believing space is distant. But in truth, it's touching us constantly. The only question is, what will touch next? For once, humanity isn't waiting for fate. NASA, ESA, and international partners are working on planetary defense systems, projects like DART, the Double Asteroid Redirection Test, which in 2022 successfully altered the orbit of a real asteroid, proving deflection is possible. Other methods are in development: gravity tractors, which use slow, steady pulls to nudge threats off course, and laser ablation, where focused energy vaporizes material to create thrust. Even private space companies are getting involved, testing autonomous tracking and early warning systems. But there's a catch. We can only defend against what we can see, and the universe is full of unseen wanderers. That's why international collaboration is vital. Because on the cosmic billiard table, there are no borders, no nations, no second chances. The real question isn't whether a collision will happen, but whether we'll be ready when it does. Earth spins on, unaware. The satellites above us drift like players on an invisible table, their orbits shifting ever so slightly with each passing day. And beyond them, the great game continues: stars, planets, comets, all locked in an ancient dance that began before life itself. Maybe that's the beauty of it, the fragility and precision, the chaos and control. We are part of the cosmic billiards match, not its spectators. So the next time you see a shooting star, remember, you're watching a cosmic shot that missed. And in this game, one miss means we're still here. If you want to follow the next moves in this cosmic game, hit subscribe, join the investigation, and stay with us as we uncover what the universe hides in plain sight. You've been watching Space Evidence Atlas. Until next time, keep looking up.